Tonight we leave behind the noise and the weight of daily life and drift toward a place where silence and eternity reign. In the endless darkness of space, beyond the planets and the familiar stars, a visitor passes through our solar system. It does not belong here. It was not born in the Oort cloud. It is not tied to our planets, and it does not serve our sun. It is a traveller from another star, an interstellar comet carrying the name 3I/Atlas. Imagine a wanderer moving across the galaxy for billions of years, long before the first cities rose on Earth, long before the first human words were spoken. A shard of ice and stone, stretched thin and fragile, holding within it the memory of other worlds. And now, for only a moment, it has come close enough for us to see its faint glow. The comet shines with a soft green light, whispering as if to say, "I will come only once." Its path feels like the breathing of the universe itself. It will pass by, brush near the sun, and then slip away again, back into regions where no daylight shines, and where no one has ever heard of Earth. For us it is only a fleeting encounter, but within this encounter lies a secret and a beauty that invites us to pause, to watch, and to wonder. Tonight you will hear its story, not a story of wars or kings, not of people and their ambitions, but of eternal travel through the stars, a tale written not in words but in light, in ice, and in time. Settle yourself comfortably. Close your eyes and allow this story to cradle you. The interstellar comet is already here, and all you need to do is follow it in your imagination. The darkness in which that story dissolved held other secrets. This time they were not tied to the familiar signs of the sky, but to something truly alien. People were used to comets, but Atlas was different. It appeared in the news in the summer of 2025, and even astronomers were shaken. Ordinary comets are born within our system. They retreat to its edges, hide in the Oort cloud, or wander through the Kuiper belt. But Atlas came from beyond. It was not a guest returning once in 1,000 years, but a traveller who would never return at all. Its path was a hyperbola, an orbit so stretched that its eccentricity exceeded 6. Such a value is impossible for bodies belonging to the Sun. Astronomers gave it a name, but a name could not tame it. Before Atlas, such objects had been detected only twice. In 2017, Oumuamua appeared, a strange elongated shard, like debris ejected from a foreign system. In 2019 came Borisov's comet, similar to ordinary comets, only far too swift. Atlas became the third. You could say that in all of history, humanity has noticed only 3 such visitors, and each time it felt like a curtain was pulled back for a moment, revealing another world. For centuries, people feared comets. In medieval European chronicles, they appeared as omens of disaster. Before the death of kings, before wars, before famine. In 1066, when Halley's comet blazed across the sky, it was recorded on the Bayeux Tapestry, as if the heavens warned of William the Conqueror's invasion. In 1315, when the Great Famine began, monks wrote of tailed stars, as if the sky knew that people would soon boil tree bark and grind acorns to survive. But all of those comets were ours, frightening, mysterious, yet still children of the sun. Atlas was different. Reading about it, you realize this is not a harbinger of doom, not a celestial sign, but a fragment of another universe passing by. It carries the dust of alien worlds, formed billions of years ago, perhaps before Earth itself. Its home star may have long since died, collapsing into a white dwarf or disappearing entirely while Atlas kept flying. Its presence in our system is pure chance, a fleeting contact, after which it will vanish into the unreachable dark where our instruments cannot follow. The discovery was made on July 1st, 2025. The Atlas survey in Chile recorded a faint object against the background of distant stars. At first it looked ordinary, just another dim speck among thousands. But soon it became clear the orbit was different. Calculations showed the object was not bound to the Sun. It was simply passing by, at a speed of about 58 kilometers per second, on a trajectory that would carry it back into interstellar space. Initially, it was labelled with the dry designation A11PL3Z. Such names stir no emotion. They are made for catalogues, but within days, once it was recognised as interstellar, it was acknowledged as unique. They named it Atlas, after the system that found it. News outlets published photographs, a faint, slightly elongated dot. Telescopes revealed a coma and a faint tail, barely visible, but enough to prove the object was active. Its ice was waking. This was no bare rock like Oumuamua, but a comet, only a foreign one. When astronomers recalculated its orbit, they realised Atlas had an eccentricity greater than 6. For comparison, Halley's comet is about 0.97. Long-period comets from the Oort cloud hover just over 1, sometimes 1.0001. Anything above 1 means the object will escape the system. But 6, that is undeniable proof. Atlas will never return. It was and would remain a wanderer. Looking at these numbers, you understand this is not just another celestial dot. It is a galactic artifact. A body travelling across billions of years, brushing against our space by accident. Its birthplace could have been anywhere in the Milky Way, in the thin disk where stars rotate, or the thick disk where ancient stars still carry the dust of the beginning. Atlas may be more than 7 billion years old. Some reports even suggested it might be the oldest cometary object humanity has ever seen. Observing it is difficult. By late summer 2025, it had passed through Ophiuchus, Scorpius, and Libra. Its brightness was fainter than magnitude 12, visible only through good telescopes. To the eye, it remained invisible, but to science it was a rare opportunity. Atlas immediately raised many questions. Why was it active so far from the Sun? At more than 3 astronomical units, ice usually lies dormant. Water cannot sublimate there, sunlight is too weak. But in Atlas's coma, astronomers found carbon dioxide. It was CO2 that awakened the comet in the outer reaches. This was unusual. In our system, most comets are driven by water ice. Here, CO2 was the main engine. Photos showed a faint green tint. The press declared, "The comet glows green." Normally that glow comes from C2 molecules, but Atlas had almost none. Scientists puzzled, what was causing the light? Perhaps rare molecules seldom found in our comets. Atlas turned out to be both familiar and alien. It had a tail like any comet, but its chemistry was not ours. It had an orbit, but one carved from another universe. It had a name, but behind it was something that resisted every familiar explanation. The story of Atlas's discovery did not begin with sensational headlines, but with an ordinary telescope image, where a faint dot blended with distant stars. Only a careful glance noticed. The motion was not what it should be. For the astronomers on duty at the Atlas survey in Chile on July 1st, 2025, it was just another working day. A wide-field sky scan, thousands of sources, routine work. On the image, a tiny bright speck, no different from many others. Dozens of such points are recorded in a single night, but the computer flagged it. The trajectory was far too unusual. At first it looked like a mistake. Astronomers were used to the software confusing noise with motion, but checks confirmed it. The object was indeed shifting differently than asteroids or long-period comets. Within a day, calculations showed the orbit was hyperbolic. That could only mean one thing: it had come from beyond. Atlas was first given a dry designation, the 11PL3Z. In the catalogue it looked routine, nothing more than a number. No one rushed to cry "Discovery of the Century." But when, a few days later, it became clear that the eccentricity was greater than 6, everything changed. No comet in history had ever shown such a value. You can imagine how it unfolded within the scientific community. At first, a modest report of a faint dot, then recalculations, and suddenly the realization we were looking at the third interstellar object in history. Oumuamua and Borisov were still being debated, and now a new one had come. This time, it revealed itself as a true comet. Coma, tail, and gas activity. The Atlas system that gave it its name had never been designed for interstellar discoveries. It was created as an early warning program for asteroids threatening Earth. 4 telescopes, located in Hawaii and Chile, scanned the sky to catch planet killers. The irony was that instead of danger to humanity, they caught a messenger from another world. These telescopes operated automatically, and most images would have gone unnoticed if not for the anomaly in the trajectory. Within days, the news circled the globe. A new interstellar object had been found. For the general public, it sounded distant, abstract. For astronomers, it was a shock. Atlas quickly became one of the most observed objects of the summer of 2025. Telescopes around the world turned toward it. Even space observatories like Hubble and Swift joined in. Every day brought new data. Photometry, spectra, polarization, all of it adding up to a picture that did not fit into familiar frames. News outlets published images: a faint green glow, a thin tail, a weak coma. Headlines declared that the comet had grown a tail. On social media, people joked that aliens are waving at us with a green lantern. But behind the humour, real science was unfolding. Scientists analysed its chemistry. The first spectra revealed carbon dioxide as the dominant driver. For comets of the solar system, this was as typical. Usually water drives activity. But Atlas was behaving differently. It began releasing gas at great distances before it had even approached the Sun. In August 2025, while it was still more than 3 astronomical units away, activity was already recorded. This peculiarity sparked debate. Some researchers suggested its nucleus contained more carbon dioxide than water, implying it formed in the cold zone of its native system, where water was buried too deep while CO2 remained closer to the surface. Others argued it might be covered by a dust layer, blocking water sublimation and making carbon dioxide more prominent. Telescopes detected not only gas. The spectrum revealed nickel, carbon monoxide, traces of sulfur compounds. Yet the classic carbon molecules like C2 were almost absent. This made Atlas unique. Amid scientific publications, a sensational version appeared. In August, Professor Avi Loeb once again suggested perhaps this was an artificial object. His reasoning pointed to the orbit lying almost exactly in the ecliptic plane. The odds of that happening by chance, he argued, were small. NASA responded quickly. Official press releases emphasized Atlas behaved like a comet. It produced gas and dust, responded to heat, and displayed all the signs of a natural body. But the public still gravitated toward the word aliens. The story of Atlas became an example of how science and popular culture move in parallel. scientists saw a rare chance to study material from another system. Ordinary people saw a sign of hope or of fear. By September 2025, Atlas was moving across the constellation of Libra. Its brightness remained at about magnitude 12 to 13, but telescopic images showed an increasingly distinct tail. The coma was growing. Observation became more difficult due to solar conjunction. It drifted too close to the Sun, and ground-based telescopes were losing sight of it. In scientific papers, researchers reported record polarization of its dust. The measurement, minus 2.7% at a phase angle of about 7 degrees, did not resemble anything seen before. Even Borisov's comet had looked different. This raised the thought, perhaps we were dealing with a new class of objects. Atlas turned out to be more than a speck in the sky. It became a symbol that the galaxy is full of wanderers, sometimes stepping into our neighborhood. Humanity realized that such discoveries would only grow more frequent. The Vera Rubin Observatory, set to begin full surveys by the end of the decade, could bring dozens more. For science, Atlas was both a puzzle and a gift. For the public, it was a symbol of the unknown. For history, it was the third witness to the truth that we are not alone in our cosmic solitude. The name Atlas was fixed in the catalogues, and along with it came the feeling that scientists had been handed a rare key to understanding how worlds are born and how they die. This time it was not only light but also chemistry that revealed its secrets. When the James Webb Space Telescope turned its infrared instruments toward the faint comet, its spectrum lit up with a familiar yet unexpected pattern. The main component of the gaseous coma was carbon dioxide. Its abundance was 8 times higher than that of water. For comets in the solar system, such a ratio is rare, almost impossible. Normally they awaken through the sun's heat, when water ice begins to sublimate. But here water was almost silent, while carbon dioxide streamed outward in torrents. The outflow of water molecules was measured in August 2025 with the ultraviolet Swift telescope. By analysing the emission lines of hydroxyl, scientists calculated that about 40 kilograms of water per second were leaving the nucleus. For an ordinary comet at that distance, this would have been little, but in the case of Atlas, it was surprisingly much. It suggested that nearly 1/5 of its surface was active. This immediately raised questions. What is the structure of its nucleus? Is it a block of compressed ice laced with rock, or is it loose and porous, like a sponge soaked in gases? Perhaps the surface is coated in dust, allowing carbon dioxide to escape more easily while suppressing the sublimation of water. Scientists detected other substances as well. The spectrum revealed carbon monoxide, sulfur compounds, and traces of nickel. Its dust contained particles that scattered light in unusual ways. In September 2025, the first polarimetric results were published. They showed an extraordinarily deep negative polarization, minus 2.7% at a phase angle of 7 degrees. No comet had ever yielded such numbers before. Even Borisov, Atlas's interstellar predecessor, had looked different. The data accumulated like a mosaic. Each fragment confirmed Atlas was not just a comet, but a witness from another epoch. Perhaps it formed near a star where conditions were utterly different from our own, where temperatures kept water locked away, and carbon dioxide became the primary building block. Polarimetric observations also hinted that its dust was exotic. The particles might be unusually small, or they might have a strange internal structure. The strong negative polarization suggested they refracted and reflected light in unfamiliar ways. It meant Atlas could represent a new type of interstellar body, unlike any we had yet encountered. Its chemistry and its glow suggested another thought: age. If Atlas truly came from the thick disk of the galaxy, where stars are older than the Sun by billions of years, then it might predate Earth itself. Scientists cautiously spoke of an age greater than 7 billion years. That would mean it carries material from a time when the Milky Way was still weaving its spiral arms, when our planet did not yet exist. While the public saw brief news items and green-tinged photographs, arguments raged in laboratories. Some claimed its unusual chemistry was a reflection of the conditions of its birth. Others argued we were witnessing processes that simply do not occur in our system. In any case, Atlas had become a mirror, one that reflected not only another system, but also our own ignorance. When telescopes registered its faint glow, there seemed to be the imagined scent of dust in the air. Anyone studying the spectra felt a strange physical closeness to the object, as if you could taste the cold bite of frozen gas, the bitterness of carbon dioxide frost breaking free through cracks. There was a bodily quality in this. Space no longer seemed empty but tangible, almost touchable. By this point, Atlas was no longer just numbers in tables. It had become a symbol of a larger question. How many more such bodies are waiting to cross our path? And every new spectrum, every diagram, only reinforced the sense that we were, for the first time, touching a true ancient messenger from the depths of the galaxy. Atlas's trajectory looked like a line piercing the solar system without the slightest hesitation, and in that there was a kind of cold logic. It did not belong to the Sun, it was merely passing through. In orbital tables its eccentricity exceeded 6, a figure that shouted strangeness all on its own. For comparison, even the most elongated ellipse of a long-period comet's barely rise above 1. Anything just above 1 already means a permanent departure, but 6, that was a rupture, a sign that there would be no return. In August 2025, its path brought it into proximity with Mars. The red planet passed closest to the interstellar visitor, just 0.19 astronomical units away, about 28 million kilometers. By cosmic standards, that is almost a neighborly distance. But Atlas drifted past as if without noticing. No gravitational capture, no trap, only a cold glide through emptiness. Perihelion was calculated for late October 2025. At that point, Atlas would approach the Sun to about 1.5 astronomical units, closer than Mars but farther than Earth. In such moments, ordinary comets brighten, their tails swell under the solar wind. For Atlas, it would be a moment of truth. Would its activity intensify? Would its tail grow longer? Would the coma change colour? After this passage, its path would carry it outward toward the giant planets. In March 2026, it would pass relatively near Jupiter, about 0.36 astronomical units away. For the giant with its immense mass, this offered a chance to nudge the orbit slightly. But even Jupiter could not capture the interstellar wanderer. Its velocity was too high, about 58 kilometers per second, like crossing the distance from Warsaw to Moscow every single second. Such numbers look dry on paper. In reality, they mean that even humanity's most powerful rockets could not catch it. The fleeing object was gone forever. That is why talk of missions to Atlas remained purely hypothetical. Theoretical papers discussed launches using gravity assists, nuclear propulsion, and decade-long journeys. But the reality was simple. To Atlas, we are too slow. In December 2025, it would make its closest approach to Earth. The distance, about 1.8 astronomical units, or 270 million kilometers, not dangerous. Even at its nearest, it would remain a faint dot in telescopes, invisible to the naked eye. Yet the very fact that such an object had crossed our sky would be preserved in the chronicles. In the heavens, its motion looked like a slow glide. In August, through Ophiuchus and Scorpius. In September, through Libra. From there, it drew closer to the sun, becoming harder to spot from the ground. This sky seemed to hide it, granting only a brief glimpse of its visit. Atlas was no threat. Its minimum distance excluded collision. But it was a reminder: space is not empty. Wanderers pass through our system carrying the chemical and physical codes of alien worlds. Each one is like a letter from the distant past, written not in ink but in dust and gas. When astronomers spoke of its trajectory, they saw more than mathematics. The line of Atlas's motion resembled the breathing of the universe, cold, steady, without pause. It came out of darkness and would return to it. There was something almost philosophical in that. We are witnesses, not masters. Telescope images recorded a green glow, a faint aura, a thin tail. In late September, the coma measured about 10 arcseconds across. Nothing to the naked eye, but to science, it was an entire atmosphere of an alien body. In that haze lay ice that once had been water or carbon dioxide, in a system where there may now be no star at all. Atlas did not speak. It left no sound, only light. Yet in that light its story was felt. You could sense the taste of cold, as though you had breathed in the air of a winter night. You could hear silence, like snow falling in an empty room. And in that silence there was more meaning than in 1,000 pages of textbooks. When its trajectory carries it beyond the reach of our system, we will no longer be able to follow it. By 2027, Atlas will be too faint for any telescope. It will become invisible again, dissolve into the depths of the galaxy. But its trace will remain, in papers, in catalogues, in the memory of those who managed to glimpse it. The calculated orbit of Atlas astonished even experienced astronomers. Its path almost perfectly coincided with the plane of the ecliptic, as if someone had deliberately drawn it along the very road on which the planets travel. The probability of such alignment seemed vanishingly small. Most interstellar objects should enter the system at steep angles, skimming diagonally like stray arrows. But here the trajectory looked as though it had been aligned with a ruler. Scientists calculated the probability of such an event and came up with a figure under 1%. In some interviews, the number 0.2% was mentioned. For science, that was not just rare, it was almost implausible. And it was this detail that fueled a wave of speculation. What if Atlas was not just a lump of rock and ice, but something constructed? Newspapers and websites eagerly picked up the theme. Headlines spoke of a cosmic probe from another system, of a ship gliding along the ecliptic. Comment sections filled with questions. If the object was flying so precisely, why should we assume it was only by chance? People are accustomed to seeing intention in every oddity, especially when it involves the cosmos. For astronomers, of course, the picture was calmer. They knew that statistically rare events do sometimes occur, yet in this case, the geometry of the orbit was almost provocative. It coincided with the plane where Earth, Venus, Mars, and the other planets circle the Sun, as though Atlas had chosen to pass exactly where we could observe it best. Some recalled Oumuamua. That object too had sparked hypotheses of artificial origin, its elongated shape, its strange acceleration, its lack of a tail. Against that backdrop, Atlas became a new spark for the imagination. The difference was that Atlas behaved like a classical comet. It had a tail, a coma, activity. and yet the orbital coincidence remained a fact. When you looked at the trajectory map, it seemed like a thread stretched across the solar system, a clear line running past Mars, past the Sun, and then outward again. And you began to feel a strange unease. Why exactly this path? Why not a steep angle? Why not a grazing entry? Why precisely along the ecliptic? In early August 2025, when the calculations were confirmed by independent groups, a second wave of debate began. Now people argued not only about chemistry and spectra, but about the meaning of the trajectory itself. Articles in scientific journals explained, yes, it is rare, but not impossible. On forums, though, posts multiplied about a cosmic drone, a test of humanity, a signal from others. And here the body intruded. You stared at the lines on the screen, and a chill went through you, as though someone had drawn an invisible mark the guest had to follow, and that mark ran straight across the place you live. The unease lingered. This was not just an object. It was an event that touched everyone. Archives quickly yielded examples of comets with trajectories close to the ecliptic, but never with such eccentricity, never with such speed. Atlas stood out like a bright scratch on a polished surface. Its path resembled a note found by accident, where every word seemed written too carefully. Research groups kept carefully explaining that an artificial nature was extremely unlikely. Yet alongside the dry calculations, a new mythology was growing. People began inventing stories, just as in the past they invented tales of war and famine when faced with tailed stars. The only difference was that now the stories were born not at campfires or in monasteries, but in news feeds and comment threads beneath videos. For science, Atlas remained unique. Its trajectory gave a chance to peer into the mathematics of coincidence. For everyone else, it brought unease and a quiet fear that behind that straight line lay someone's intent. The strangeness of Atlas did not end with its path lying almost flat in the ecliptic. Its motion revealed another secret. The orbit was retrograde, tilted only slightly, yet flowing against the natural spin of the solar system. Most comets, asteroids, and planets move in the same general direction. The ancient imprint of the nebular cloud that collapsed to form our system 4.5 billion years ago. Atlas cut against this grain, an intruder drifting upstream like a single fish, forcing its way through the current of a river. Its inclination measured barely 5 degrees. For an interstellar traveller, this near-flat entry was unsettling. Objects falling into our system usually arrive from high latitudes of the celestial sphere, their angles steep, their speeds erratic. Atlas, by contrast, seemed to slip in quietly, as if it had always known where the planets waited. Retrograde motion means more than just moving the wrong way. It means encounters are swifter, more violent in relative terms. Each meeting with dust, with the solar wind, even with light itself, happened at heightened energy. When Atlas approached the Sun, it felt the bombardment of photons and particles like icy sand whipped into its surface. At nearly 58 kilometers per second, every grain of cosmic dust struck it with the energy of bullets. A fragile, icy body should not survive such punishment for long, yet Atlas endured. The velocity itself was a signature of its origin. In orbital mechanics, the escape speed from the Sun at Earth's distance is about 42 kilometers per second. Atlas moved faster. Even as it fell inward, pulled by gravity, it already possessed more than enough to leave again. This is why its trajectory drew a hyperbola. Unlike the closed loops of ordinary comets, Atlas's curve was open-ended, a wound in the geometry of the solar system. Observers described it as an object just passing through, but that phrase hides the violence of the journey, retrograde, high speed, shallow angled. These were all stressors. For the coma, it meant gas ripped away and spread chaotically. For the dust tail, it meant sudden disruptions whenever the solar wind shifted. Astronomers expected and even predicted that at some point Atlas's plasma tail could be torn off entirely in a disconnection event, a common fate when interplanetary magnetic fields strike a comet. The numbers painted the picture. Speed, 58 kilometers per second. Inclination, 5 degrees. Eccentricity, over 6. No familiar comet carried such values. Even Borisov, the second interstellar comet discovered in 2019, came in at a steeper angle and with a slower glide. Oumuamua in 2017, the first interstellar visitor, never displayed a tail at all. Atlas combined the velocity of one with the activity of the other, a hybrid case that puzzled every researcher. Retrograde motion also affected the way light scattered in its dust. Polarimetric studies suggested that at certain angles Atlas absorbed light rather than reflecting it in the expected manner, producing its record-breaking negative polarization. These subtleties were not just optical tricks. They told of the shape and texture of its dust grains, of chemical bonds preserved since the dawn of another star. When astronomers simulated its approach on computers, the orbit line crossed the screen like a scar. Planet after planet moved forward in their slow circles, while Atlas slipped against them, opposite, indifferently fast. It reminded them of the Great Comet of 1680, one of the brightest in recorded history, which also had a steeply retrograde orbit, but that comet belonged to our Sun, its eccentricity less than 1, destined to return. Atlas would not. To stand at a telescope and know these numbers was not an abstract experience. The body reacts. Fingers stiffen in the night air, breath fogs the eyepiece, and eyes ache from hours of tracking a faint blur among the stars. Yet beneath that discomfort comes the bodily sense of speed. That thing you are looking at is rushing faster than any planet, faster than any spacecraft ever built. A comet that defies the current, burning quietly, carrying an orbit no one could mistake for local. It was not a question of whether Atlas would stay. Its speed, its retrograde cut through the solar system, already declared its fate, to come and go like a voice carried on the wind, heard once and never again. All calculations pointed toward one date, October the 29th, 2025, when Atlas would reach perihelion, its closest approach to the Sun, at a distance of just over 1 1/3 astronomical units. For astronomers, this was the great test, the weeks before perihelion or when a comet shows its true face. Will its activity surge, its tail grow longer, its glow brighten? Or will it wither under the pressure of heat and collapse into fragments? Perihelion means sunlight striking harder, photons hammering the surface, the coma swelling with released gas. For Atlas, whose chemistry was already unusual, the expectation was electric. If water ice was buried deep, this was the moment it could finally erupt. If carbon dioxide dominated, then jets of cold breath might become torrents, spraying dust into a larger, greener halo. The numbers set the stage. 1 astronomical unit is the Earth's distance from the Sun, about 150 million kilometers. At perihelion, Atlas would pass at 1.36 to 1.4 astronomical units between Earth and Mars, far enough to remain distant but close enough to feel the furnace. The Sun at that range is more than 50% stronger than what Earth receives. An icy body feels it like fire. Comets in perihelion often transform. Some brighten 100-fold visible to the naked eye. Others crumble, their nuclei torn apart by thermal stress. the Great Comet of 1843 developed a tail 200 million kilometers long at its perihelion. More recently, Comet YSON in 2013 disintegrated in its brush with the Sun, leaving only a fading smear. For Atlas, no one knew which story it would follow. Through telescopes, observers prepared. Late October skies placed Atlas near the Sun, low and difficult to watch. The glare of daylight swallowed it for many, but space telescopes could still record. Instruments tuned for ultraviolet and infrared were pointed, ready to capture every molecule that escaped. The smell of dust and frost seemed to hang in the imagination. Not real, but a sensation evoked by numbers on a chart, by the knowledge that ice was boiling in the void. The tail at this stage could change dramatically. Solar wind pressure rises near perihelion, forcing the plasma tail into a long streamer. At times, such tails snap, disconnection events, when coronal mass ejections sweep through. Already in September, forecasters noted that a CME launched from the Sun might pass near Atlas around its perihelion week. If so, its tail could tear and then regrow, a celestial wound healing in real time. Perihelion is not just geometry, it is an ordeal. The nucleus, perhaps only a few kilometers across, must endure tidal forces, radiation, sublimation. Every crack and pore vents gas, every shadow hides potential collapse. Astronomers speculated, if Atlas was fragile, this could be the moment it shattered. If strong, it could survive, darkened but intact, and glide outward trailing its scar. On Earth, nights grew colder as October deepened. Observers bundled in coats, frost clinging to their instruments, breath steaming in the air. They tracked the object's curve in software even when the glare made it invisible. The sense of anticipation was physical, shoulders tense, skin prickled, as if the body knew a trial was underway millions of kilometers away. The calendar date itself, October 29th, carries no magic, yet in this context it became a kind of milestone. Generations before had watched comets at their perihelia with the same anxious awe. Halley's Comet in 1910, brushing close to Earth's orbit, inspired panic and fascination. In 1680, Newton himself calculated the terrifying plunge of a great comet into the Sun's vicinity. Atlas joined that tradition, another icy wanderer daring the furnace. What would remain after perihelion was uncertain. Some comets split, their fragments leaving multiple tails. Others lose brightness suddenly, their activity quenched. The only certainty was that Atlas would not turn back. Even if it survived intact, the hyperbola remained open, carrying it away. Perihelion was not a rebirth but a climax, the moment of greatest exposure before retreat. October the 29th approached like the crest of a wave. Astronomers readied instruments, compared notes, argued predictions. Outside the observatories, the world was unaware, the date just another autumn day. But within the quiet rooms filled with humming equipment, the tension was palpable. A body from another star was about to show how it faced the Sun. After perihelion, Atlas turned its back to the Sun and began the outward leg of its hyperbolic path, a trajectory that would never curve back. The calculations were clear. Even the gravity of the giant planets could not capture it. By December, its course carried it past Earth's orbit, though never near enough to pose any danger. The closest point would come on December 19th, 2025, at a distance of about 1.8 astronomical units, more than 270 million kilometers. In human terms it was vast, but in cosmic language it was a brushstroke across our neighborhood. Observers knew that at such a distance, Atlas would never be a spectacle for the naked eye. Its magnitude, already faint, would linger beyond the reach of casual stargazing. Yet through telescopes, it was still a presence, a small, green-tinted blur, a reminder that something ancient and alien had entered our sky. By then, the perihelion heat had passed, and the comet's coma began to shrink. Gas jets subsided, dust drifted away, the halo contracted like a breath slowly released. The physics of departure echoed the physics of arrival. The retrograde path continued, slicing against the direction of the planets. Its speed, still close to 58 kilometers per second, meant that even as it receded, it would remain visible only briefly before fading. By 2027, projections showed Atlas would be lost to ground-based instruments entirely. What remained was to follow it during these final months of proximity, to catch every possible photon, every spectral line, every polarimetric reading. December nights brought their own atmosphere. The chill deepened, and astronomers in the northern hemisphere tracked Atlas through frosted observatory domes. Fingers numbed on the eyepiece controls, lenses fogged with condensed breath, and still the faint blur was logged, measured, analysed. The body's reactions, shivering shoulders, the ache of standing too long in the cold, became part of the record, as if human endurance mirrored the endurance of the comet itself. The closest approach to Earth passed quietly. No bright flare, no sudden split, no catastrophic display. Atlas remained what it had been, a faint interstellar messenger. Reports confirm the distance precisely, 1.8 astronomical units, a gulf that meant complete safety, yet enough to say it had brushed near. In some ways, the lack of drama was the drama. A body older than Earth, travelling for billions of years, had entered our system, passed perihelion, approached our orbit, and left, all within the span of a single human year. As Atlas moved outward, attention shifted to March 2026, when its trajectory would bring it within 0.36 astronomical units of Jupiter. Simulations suggested a slight deflection, a whisper of gravitational influence, but nothing strong enough to alter the inevitable. The hyperbola remained open. After Jupiter, the object would accelerate outward into interstellar space once more, untouchable, beyond pursuit. For those who followed it night after night, December was a moment of quiet reckoning. The sense of presence lingered, not because Atlas was bright, but because it was final. Each logged measurement felt like the last words of a conversation. The sky offered no sound, only the faint glow of dust and gas, but the silence was heavy, like the end of a visit you know will never repeat. In the centuries ahead, no human eye will see Atlas again. Its path will carry it beyond the limits of our telescopes, past the heliopause, into the cold between the stars. It will rejoin the anonymous population of icy wanderers, invisible, yet real, circling the galaxy as it has for billions of years. Its closest approach to Earth, December 19th, 2025, will remain as a date in records, a reminder that once, for a short time, we shared our sky with a traveller from another world. In early September 2025, observers noticed a change. The faint silhouette of Atlas had grown a halo of soft green light, as if someone had added a cold glow to its shadow. It was unexpected. In ordinary comets, a green tint is almost always linked to the C2 molecule, diatomic carbon that forms when organic compounds break apart in the tail and coma. But the spectra of Atlas showed almost no C2. So where did the light come from? Telescopes recorded the glow across different wavelengths. Visually, the coma took on a pale green hue, reminiscent of the aurora, but not in Earth's atmosphere, in the emptiness of space. Scientists describe the shade as icy, phosphorescent, unnaturally pure. For the observer staring at a monitor, it was a pixelated blur, yet for eyes used to grey smudges and numbers, it suddenly sparked the impression of living colour. The news spread quickly. Scientific portals ran headlines about cosmic neon. On social media, the comparisons multiplied. Some called Atlas a green lantern. Others joked that aliens had switched on a spotlight. The humour did not last, but it revealed something. People found it easier to tie a rare cosmic phenomenon to everyday images of the 21st century, lamps, lasers, glowing screens, than to formulas and spectra. Astronomers, however, saw a problem in the green light. If not C2, then what? They proposed rare molecules seldom observed in solar system comets. Carbonyl sulfide, perhaps, or even nickel compounds detected earlier in Atlas's spectrum. Yet no single hypothesis gave a complete answer. At the telescope, the experience was different, almost physical. The night stretched on, the air chilled each breath, fingers stiffened in the cold, and on the monitor appeared a blurred point with a greenish halo. The light worked on the body the way a fire does in darkness. It drew you closer, made you want to keep watching, made you believe there was meaning hidden inside. For the first time in all the observations, Atlas looked not just like a data point, but like an object with a face, a colour that could be described in human words. Comparisons with other comets only sharpened the mystery. Borisov's coma had been bluish. Many long-period comets glowed whitish-yellow, but Atlas was green, and the source remained unexplained. It was one of those cases where science recorded the effect but faltered in interpretation. That shade, precisely because it defied explanation, started a new wave of fascination. Atlas was no longer only a mathematical object with an eccentricity greater than 6. It had gained an image easy for the imagination to grasp: the Green Wanderer. People may not read formulas, but they remember colour. The search for the source of that green light led scientists deeper into spectra, hunting for molecules that rarely show themselves in comets of the solar system. At first, the absence of C2 was the surprise. Generations of comet studies had conditioned astronomers to expect its spectral bands, a reliable marker for the emerald glow. But Atlas whispered a different chemistry. Its spectra held gaps where carbon chains should have been, and instead hinted at lines that belonged to stranger compounds. Some suggested carbonyl sulfide, OCS, a molecule faintly detected in Atlas earlier. On Earth, OCS is part of volcanic emissions and industrial chemistry, but in a comet's coma it is rare, fragile, and quickly broken apart by sunlight. Could enough of it linger in Atlas to cast a green hue? Others pointed to atomic nickel, a feature discovered in comets only recently. Metallic atoms released by heating can radiate at unusual wavelengths, and Atlas carried traces of this metallic breath. There were still more candidates. The ultraviolet instruments of Swift had recorded hydroxyl radicals, OH, produced by water's slow release. Their fluorescence, while not usually dominant in visible light, could contribute faint shades at the edge of perception. Even carbon monoxide, CO, though largely invisible to the eye, altered the energy balance of the coma in ways that might shift the colour toward green. The difficulty was not in identifying possibilities, but in proving them. Cometary chemistry is a tangle. Every molecule broken by sunlight spawns fragments, each fragment glowing in its own way. What Atlas displayed was a chorus of subtle voices rather than the familiar solo of C2. Its glow was the product of processes layered upon processes, a labyrinth of light born from disintegration. The rarity of these molecules underscored the alien nature of Atlas. Comets in the solar system carry water as their dominant breath. They erupt with H2O near perihelion, and green comes almost as a side effect. But Atlas seemed to bypass this familiar script. Its chemistry, heavy with CO2, laced with oddities like OCS and nickel, and poor in carbon chains, was a recipe unfamiliar to our neighbourhood. At night in observatories, this difference was felt as much as seen. Eyes strained at faint screens, noses stung with the imagined bite of sulphur, throats caught the dryness of cold air, and the mind supplied sensations to match the numbers: acrid smoke, metallic taste, the sting of ice in lungs. Atlas was not only a point of data, it became a body in the senses, a foreign smell, a bitter taste conjured by thought. Comparisons to past comets highlighted the anomaly. In 1997, Comet Hale-Bopp blazed with strong C2 bands. In 2019, Borisov displayed carbon chemistry close to the solar norm. Atlas did not. Its missing molecules stood out like silence in a symphony. For researchers, this silence was as valuable as sound. It said, "Here is a body that formed under conditions we have not sampled, at temperatures and pressures different from our own cosmic nursery." The green glow became not just a colour, but a question. Each molecule proposed as its cause pointed to a different birthplace. If OCS was to blame, then Atlas might have frozen in a sulphur-rich disk around a long-dead star. If nickel contributed, then perhaps its ices had been infused with metallic grains close to a hot young sun before being cast away. If CO dominated, then its cradle lay in the outer dark, far from warmth, where only the most volatile gases could shape the surface. Thus the mystery deepened. The glow did not solve Atlas, it multiplied him. To gaze at the comet was to see a question mark shining in green, each photon of light carrying the flavour of an unknown chemistry. What began as spectral lines and quiet debate soon left the halls of science, carried outward into the language of headlines and stories. Newspapers and magazines rarely spoke of OCS or nickel atoms. They preferred phrases like cosmic neon, green messenger, a lantern among the planets. For the wider world, Atlas was no longer an icy nucleus venting gases. It was a character, a visitor, coloured vividly for imagination. The image had power. Colour travels faster than chemistry and human memory. Long before anyone could understand what molecules caused the glow, people already spoke of the green comet from another star. The metaphor spread, indifferent to data, alive with its own momentum. This transformation has deep roots. History remembers comets not only for their orbits, but for the meanings imposed upon them. In 1066, the Bayeux Tapestry depicted Halley's comet as a fiery omen above a king's crown. In 1910, Halley returned, and fear filled streets when its cyanogen was misreported as poison. In 1997, Hale-Bopp filled the skies, inspiring both awe and tragedy when cults misread its presence. Against this lineage, Atlas stood out, not bright to the naked eye, not dramatic in its path, but marked by a colour that turned into symbol. Cosmic neon was the phrase most repeated. It echoed through articles, whispered in documentaries, spoken by those who would never see Atlas through a telescope. The comparison was imperfect but irresistible. Neon belongs to the language of light humans know, signs, lamps, city nights. To bind that image to a comet was to fuse the distant and the intimate, to make alien chemistry part of familiar thought. Inside observatories, scientists read these words with mixed expressions. Some welcomed the attention. Any comet that stirred the public could bring funding, curiosity, support. Others worried the simplification erased the nuance. Atlas's glow was not a single tube of gas, but a tangled chorus of reactions, fragile molecules torn apart by the sun. Yet narrative always moves faster than analysis. Before the arguments could settle, the label had stuck. Artists painted Atlas as a ribbon of jade fire across black skies. Amateur astrophotographers exaggerated the colour in their images, creating pictures more vivid than reality. Even those who never saw it firsthand carried the green image in their minds. In silence, in darkness, Atlas was imagined as a lamp adrift between stars. Still, professional notes maintained restraint. Reports emphasized what was missing: the absence of carbon chains, the dominance of CO2, the provisional nature of every claim. Yet even in their cautious tone, there was wonder. To describe an interstellar comet as green was to admit that the unknown had entered the ordinary sky. Nights at telescopes gave this wonder texture. Frost on metal rails, breath fogging in air, the constant hum of instruments, all framed the faint blur. Eyes strained, the mind supplied sensation. The sting of cold ozone, the shimmer of invisible gas, a light that felt as if it pressed against the skin. Data became physical, embodied, even in silence. By late September, the storm of attention slowed, but the label endured. Atlas had become the green wanderer. For science, it was eccentricity, spectra, ratios. For culture, it was a colour, and colours last longer than numbers. Yet even as the name settled, the arguments did not end. Atlas divided opinion, forcing scientists to decide whether its glow was simply chemistry stretched to an extreme, or the mark of something that demanded a new category. Papers circulated in September and October 2025, their language cautious but restless. Words like anomalous and unprecedented appeared beside numbers, wrapped in hedges such as further study required. The balance between restraint and wonder was visible on every page. Some argued that nothing supernatural was needed. Atlas, they said, was built of ice and dust like any other comet. Its unusual glow was the product of a birthplace colder, richer in carbon dioxide, poorer in carbon chains. In this view, Atlas was natural, only rarer than what we knew. Others countered that such explanations missed the point. Never before had a comet displayed this precise combination, this silence of C2, this chorus of unfamiliar lines. If Atlas was natural, it was still outside the spectrum of our expectations. At conferences, the air itself felt charged. Voices rose, questions pressed, charts flickered on screens. Some leaned forward with excitement, others crossed arms in suspicion. You could almost hear 2 centuries of comet lore arguing with itself, the tradition of treating comets as omens colliding with the modern urge to catalogue them as data. The telescope nights mirrored the debates. Instruments clicked, domes shuddered open, cold metal rails gleamed with frost. Observers squinted at faint halos, their own bodies stiff with the ache of waiting. You felt the weight of silence, the way your breath turned white in the air, the way the stars seemed to draw back and leave Atlas alone at the centre. In that moment, it was impossible to call the glow ordinary. Others reached further, suggesting that Atlas might hint at processes that blur the line between comet and something else, a hybrid category not yet written in textbooks. Was it an object frozen in an alien disk where sulfur and metal grains dominated? Was it the shard of a disrupted planetesimal, carrying chemistry once locked in a mantle? Every possibility stretched the imagination, The longer Atlas stayed, the sharper the division grew. For some, every spectrum was confirmation of nature's variety. For others, every gap was a question mark too loud to ignore, and you, reading the reports late at night, felt both currents tugging, the desire for a simple explanation and the thrill that maybe simplicity would not be enough. By November, the arguments had no winner. Atlas itself gave no answer, only light. Its green glow persisted, shrinking slowly as it drifted farther from the sun, but never clarifying its cause. The comet remained a riddle, and perhaps that was the truest lesson. Not every visitor explains itself. Some come only to remind us how narrow our categories are, how much remains outside the boundaries we draw. Yet even as the name settled, the arguments did not end. Atlas divided opinion, forcing scientists to decide whether its glow was simply chemistry, stretched to an extreme, or the mark of something that demanded a new category. Papers circulated in September and October 2025, their language cautious but restless. Words like anomalous and unprecedented appeared beside numbers, wrapped in hedges such as further study required. The balance between restraint and wonder was visible on every page. Some argued that nothing supernatural was needed. Atlas, they said, was built of ice and dust like any other comet. Its unusual glow was the product of a birthplace colder, richer in carbon dioxide, poorer in carbon chains. In this view, Atlas was natural, only rarer than what we knew. Others countered that such explanations missed the point. Never before had a comet displayed the precise combination, this silence of C2, this chorus of unfamiliar lines. If Atlas was natural, it was still outside the spectrum of our expectations. At conferences, the air itself felt charged. Voices rose, questions pressed, charts flickered on screens. Some leaned forward with excitement, others crossed arms in suspicion. You could almost hear 2 centuries of comet lore arguing with itself, the tradition of treating comets as omens colliding with the modern urge to catalogue them as data. The telescope nights mirrored the debates, instruments clicked, domes shuddered open, cold metal rails gleamed with frost. Observers squinted at faint halos, their own bodies stiff with the ache of waiting. You felt the weight of silence, the way your breath turned white in the air, the way the stars seemed to draw back and leave Atlas alone at the centre. In that moment, it was impossible to call the glow ordinary. Others reached further, suggesting that Atlas might hint at processes that blur the line between comet and something else, a hybrid category not yet written in textbooks. Was it an object frozen in an alien disk where sulfur and metal grains dominated? Was it the shard of a disrupted planetesimal, carrying chemistry once locked in a mantle? Every possibility stretched the imagination. The longer Atlas stayed, the sharper the division grew. For some, every spectrum was confirmation of nature's variety. For others, every gap was a question mark too loud to ignore. And you, reading the reports late at night, felt both currents tugging. The desire for a simple explanation, and the thrill that maybe simplicity would not be enough. By November, the arguments had no winner. Atlas itself gave no answer, only light. Its green glow persisted, shrinking slowly as it drifted farther from the sun, but never clarifying its cause. The comet remained a riddle, and perhaps that was the truest lesson. Not every visitor explains itself. Some come only to remind us how narrow our categories are, how much remains outside the boundaries we draw. The riddle grew deeper when the James Webb Space Telescope turned its instruments toward Atlas, revealing chemistry unlike anything seen before. infrared spectra carried the unmistakable fingerprints of carbon dioxide, not as a trace but as the dominant voice. The ratio of CO2 to H2O was measured at about 8:1, the highest ever recorded for a comet. Where most comets breathe water as their primary gas, Atlas exhaled carbon dioxide, as if it belonged to a different script of creation. This discovery shifted the tone of every discussion. Numbers speak coldly, yet these numbers shocked. Water almost silent, carbon dioxide overwhelming. The usual hierarchy of cometary volatiles had been inverted. Instead of H2O leading with CO2 and CO trailing behind, Atlas lived in reverse. For scientists used to the solar norm, this was like hearing a familiar song played backward. They looked for calibration errors, checked instruments again, compared Webb's results with ground-based data. Yet the conclusion remained. The comet's coma was almost entirely CO2, with water lagging far behind. Why does this matter? Because water is not just another molecule. It defines habitability, it defines thermal response, it defines how a comet brightens when it nears the sun. A water-rich comet wakes at 2 astronomical units, grows violent by 1 astronomical unit, and spills its life into the sky. Atlas had already stirred at more than 3 astronomical units, powered not by water, but by carbon dioxide. That alone marked it as alien to our catalogue. The implications reached far. If Atlas formed in a region rich in CO2, then its birthplace lay farther from its star than our comets, in zones where water locked deep while carbon dioxide froze nearer the surface. Or perhaps it condensed in a disk where stellar chemistry itself was different, oxygen scarce, carbon dominant. Every explanation meant a system unlike our own. The Webb data carried a sensory weight. Charts showed peaks for CO2 bands, valleys where H2O should sing. To read them was to feel dryness, the cold taste of carbon frost, the sting of air without moisture. You imagine the comet not as a damp body sweating water vapour, but as a dry one exhaling bitter cold gas. The media seized on the numbers. One headline called Atlas the Dry Comet, another dubbed it the CO2 Wanderer. In discussions, people compared it to climate reports. Here too, carbon dioxide dominated the story, though on a cosmic scale. The parallel was imperfect but irresistible. The same molecule that warms Earth by trapping heat was, in Atlas, the very breath of its existence. For observers at telescopes, the difference was felt in subtler ways. They watched a coma that behaved oddly, bright yet brittle, swelling not in sync with solar distance as water-driven comas do. The graphs of brightness versus distance drew crooked lines, not the neat curves textbooks predicted. You stared at those lines and sensed unease. Atlas did not obey the rules. It was not just one anomaly, but the combination. Green light unexplained, C2 absent, carbon dioxide overwhelming. Taken together, the portrait was not of a comet that bent the rules, but of one that rewrote them. The numbers seemed quiet at first glance. 40 kilograms, less than a human truckload, vanishing each second. But scaled across days, weeks, months, it became a river. For Atlas, it meant that nearly 1/5 of its surface might already be active, a fraction almost unheard of. Comets in our system rarely show such vigour at such distance. To watch this through instruments was to sense paradox. The comet glowed faintly, its coma no brighter to the naked eye, yet in ultraviolet it sang. You sit at the console, air dry around you, and realise that ice hundreds of millions of kilometres away is boiling into space. The mind supplies the sensation, a taste of frost on the tongue, a sting of cold air as if you had opened a freezer and leaned too close. Why so early? At 3.5 astronomical units, the sun's warmth is weak. Water ice, buried deep, usually waits until 2 astronomical units or less before it begins to vaporize. Atlas, however, was awake already. Carbon dioxide had roused it, but now even water found its way out. Cracks in the crust may have opened, vents may have carried hidden reserves to the surface. Perhaps the structure itself was porous, fragile like snow, allowing sublimation long before the heat was strong enough. Swift's detection confirmed Atlas as more than a green light. It was active, noisy, alive in physical terms. Scientists compared graphs, recalculated thermal models, argued over the meaning of such early release. For some, it suggested a shallow layer of ice exposed by impacts. For others, it pointed to a unique composition, a body built from materials that respond differently to sunlight. The observation gave Atlas weight, made it tangible. It was no longer only a curve on orbital charts, it was vapor, expanding, scattering photons, leaving fingerprints in spectra. And you, tracing those fingerprints, felt how fragile distance is. Space might be empty, but molecules once hidden in ice were now carried across millions of kilometers to register on a detector's plate. The cold physics carried warmth of meaning. Atlas was not static. It was breathing, hissing, spilling its contents into the solar wind. The 40 kilograms each second were not much in human terms, but in cosmic terms they were a voice, a signal that reached Earth, passed through telescopes, and entered human memory. That voice was stranger still because it spoke too soon. Water should have waited, yet Atlas released it in the cold reaches where comets usually remain silent. In the architecture of comets, water is the late riser. Carbon dioxide and carbon monoxide with lower sublimation points normally stir first, while H2O waits for true warmth. Atlas overturned this order, and that inversion rattled models long held steady. At 3.5 astronomical units, sunlight is weak. A surface there feels less than 1/10 of the heat Earth receives. For water ice, buried under regolith or crust, such radiation is not enough to free it. Yet Atlas did not obey. Its OH signatures rose clearly, proof that vapor had broken through. Astronomers wrestled with explanations. Perhaps fractures had split the surface, exposing shallow ice. Perhaps impacts had scarred the nucleus, leaving vents from which vapor escaped. Or perhaps the comet was inherently porous, a lattice of fragile ice grains that allowed water to seep outward, even under the weakest touch of light. Thermal models struggled, equations predicted slumber, observations confirmed activity. The mismatch spoke loudly. You look at such graphs, lines refusing to align, and feel the friction between expectation and reality. The comet, small and far, seemed to bend the laws we trusted. The sensation for observers was bodily. Nights at telescopes were cold, instruments stiff, fingers aching as they turned focus knobs. Breath hung in the air, the sharp sting of frost on lips. Yet what reached them was even colder. Water vapor freed where it should have remained locked. The paradox sank into skin, not only into charts. Comparisons rose quickly. Other comets had been seen active at large distances, but most owed that to volatile gases like CO. Water, stubborn and slow, rarely joined so early. Atlas, however, had joined the chorus long before it was expected. The strangeness lay not just in numbers but in timing. In discussion, scientists returned to language that betrayed awe. Words like premature, anomalous, enigmatic release appeared beside formulae. Reports reminded readers of the distance, 3.5 astronomical units, nearly 525 million kilometers from the Sun, yet water already danced free. Some speculated that this might hint at internal heat, radioisotopes within the nucleus giving a faint warmth. Others dismissed it as unlikely. Such heating would be minimal after billions of years. Still, the fact remained. Atlas had spoken with water before the script allowed. For those who followed, the early activity became a symbol. It told of a body both fragile and ancient, porous yet enduring. And you, reading those careful notes, felt the weight of wonder, that even in silence, even in cold, Atlas found a way to exhale. The story of Atlas's breath widened further when spectra revealed not only water and carbon dioxide, but rarer voices, carbon monoxide, carbonyl sulfide, even traces of atomic nickel, while the familiar carbon chains were almost absent. In the usual grammar of comets, C2 sings clearly, painting tails with green fire. Here that line was nearly silent. Instead, new elements stepped forward, reshaping the melody into something unfamiliar. Carbon monoxide, CO, left its faint but steady mark. With a sublimation point even lower than CO2, it can drive comets awake at the farthest distances. Its presence explained some of the early stirring, but not the colour, not the full texture of Atlas's glow. Then came carbonyl sulfide, OCS, a rare molecule on Earth associated with volcanic breath and fragile in sunlight. Its detection in Atlas hinted at exotic chemistry. Sulfur bound with carbon, carried intact from a nursery star now lost. Perhaps the strangest were the metallic lines. Nickel atoms, free and unbound, glimmered in the spectrum. Metals do not usually appear so cleanly in cometary comae. They hide within dust, bound in grains. Yet Atlas exhaled them directly, as though its ices had trapped metallic breath that now slipped free. You read those lines and imagine the taste of metal on your tongue, a cold, sharp tang that seems out of place in the silence of space. Water ice too showed its hand, crystalline fragments scattering light. But even here the pattern differed. Ratios mismatched, balances skewed. Atlas was a ledger with columns crossed out, rewritten, incomplete. You trace them with your eyes, following every dip and peak, and feel the unease of studying a language where letters have been rearranged. The absence of C2 shouted louder than its presence ever could. For centuries that molecule has been the signature of comets. It explains the classic green that crowns so many visitors. To find Atlas nearly mute in C2 was like hearing a symphony without its main instrument. Still music, but eerie, unbalanced. Scientists debated, was this depletion a clue to its origin? If Atlas had formed in a disk where carbon chemistry took another path, then its silence was testimony, not accident. Perhaps its parent star's disk lacked the conditions to assemble these molecules. Perhaps cosmic rays had shredded them long ago. Whatever the cause, the result was absence, and absence too is evidence. In observatories, the discussion became tangible. You stand in the dim glow of screens, the hum of instruments steady, and see the graphs unfold. Peaks rise where you expect valleys, valleys where peaks should climb. The body reacts before the mind. A frown, a shiver, the tightening of your grip on a pen. The comet speaks in riddles, and you feel the riddle seep under your skin. Atlas's spectrum became less a list of compounds and more a mirror of strangeness. CO, OCS, nickel, water ice. Together they painted a portrait no comet of our system had worn. Not chaotic, but alien in harmony. In this portrait, absence was as loud as presence, silence as meaningful as sound. By late 2025, the consensus had not arrived. Atlas remained what it had been from the start, a question carved in ice, its chemistry a reminder that other systems may write comets differently. Some notes overlap, others vanish, new ones emerge. To study Atlas was to realize that the universe composes with a broader palette than we imagined. The strangeness did not stop with chemistry. When astronomers measured how Atlas scattered light, the results broke records, revealing a depth of negative polarization unseen in any comet before. At small phase angles near 7 degrees, Atlas dipped to negative 2.7%, a valley no cometary dust had reached. This number might sound abstract, a detail buried in optics, but to the specialists it was a shock. Comets, asteroids, even interplanetary dust clouds had shown negative branches before, but never this deep, never this narrow. Polarization measures the orientation of a light waves after scattering. Normally, sunlight striking dust in a coma bounces with predictable signatures. A familiar curve dips into mild negatives and then inverts as the angle grows. Atlas defied that curve. Its line sank lower, sharper, as though its dust grains bent light in a way unknown to the solar system. For researchers, graphs became landscapes. They watched the line drop into a canyon where none should exist. You followed it with your eyes, the curve sinking past expectation, and felt the unease of ground falling away. Every photon told of dust that twisted polarization differently, whispering of textures not catalogued. Some reached for comparisons. Could calibration error be to blame? Instruments were checked, repeated, cross-verified. Each time the abyss returned, minus 2.7%. Others suggested Atlas carried dust so fine, or shaped so strangely, that scattering behaved unlike any known sample. Spheres, rods, aggregates, none matched. Atlas had dust that behaved like nothing in the laboratory. For the public, polarization is an invisible property, hard to picture, yet it touches familiar life. Polarized sunglasses reduce glare, smartphone screens change color under angled light. To imagine Atlas was to think of a screen tilting and refusing to show the same picture, of sunglasses that darkened far beyond design. The comet had turned the sky into an optical trick no one could fully explain. Reports framed it cautiously. Words like unprecedented, extreme, anomalous branch appeared. But behind restraint lay wonder. Dust preserved for billions of years, grains untouched since before Earth formed, might have carried structures so delicate that only interstellar exile preserved them. In observatories, the measurements were not abstract. Nights were cold, instruments hummed, and on screens the dip appeared again. You leaned closer, breath misting against the monitor, and felt the quiet thrill of touching dust that might predate galaxies' spiral arms. The numbers, austere and simple, were also sensory. Valleys on a graph that became valleys in thought. The curve did not remain in darkness. At larger phase angles it rose again, crossing the threshold near 17 degrees, the inversion point where negative turned positive. For comets and asteroids alike, this crossing is a familiar landmark. Yet for Atlas, it arrived with a sharpness and timing that deepened the mystery. The light, bent and scattered by grains untouched for billions of years, seemed to change allegiance at precisely that point, a flip from suppression to reinforcement. In ordinary comets, inversion arrives smoothly, the curve easing upward as if light were persuaded gently. Atlas's curve was abrupt, like a cliff giving way to a plateau. You watched the line vault upward, a sudden reversal, and felt the same disorientation as when a familiar melody skips into another key without warning. The meaning of an inversion angle is not trivial. It tells of size and shape, of how dust grains align under solar radiation, of the chemistry coating their surfaces. For Atlas to show such a crisp inversion at 17 degrees suggested dust that was neither like the porous aggregates of our comets nor the compact grains of asteroids. It implied something finer, stranger, perhaps layered or hollow, a structure light itself had never rehearsed against. Scientists debated whether the 17-degree crossing hinted at a narrow distribution of particle sizes, grains so uniform that their collective scattering behaved as one. Others proposed mixed populations but with properties never before catalogued. Laboratory analogues, soot, silicates, icy powders, could mimic pieces of the curve, but not the whole. Atlas remained unmatched. The inversion was more than data. It was a reminder that light carries stories in its orientation. The photons that left the sun, untouched for 8 minutes across space, collided with dust from another star and returned altered, whispering through polarimeters. Each photon was a messenger. Each carried news that the dust was different, that it bent reality in an unfamiliar way. At the telescope, the human body registered what instruments revealed. Eyes strained against graphs, shoulders stiff from long hours, the hum of equipment like a low chant in the background. You felt the inversion not as an angle but as a shift in the room, a sudden certainty that something foreign sat at the edge of perception. Numbers lined the page, but they spoke of texture, of the feel of dust your hands could never touch. Inversion angles are catalogued across decades, each comet adding its trace. None reached as sharply as Atlas. To see its line leap upward at 17 degrees was to realize that not only chemistry, but structure itself marked Atlas as alien. The dust had survived exile from its system, drift through interstellar dark and entry into ours. It carried memories of conditions long erased elsewhere. The debate over its meaning was ongoing, cautious, yet alive. Some claim the inversion could still fit into extended models of solar comets with extreme parameters. Others insisted it was a signature too different to fold back into known categories. Either way, Atlas forced light itself to testify, and the testimony was strange. From that testimony rose a possibility more haunting than any calibration error, that Atlas carried dust older than Earth, older even than the spiral arms of the Milky Way. The notion was staggering. In most comets of our system, dust is recycled, ground by collisions, reshaped by radiation. But Atlas, an exile cast into interstellar space, might have protected grains in their original form, a time capsule from the dawn of the galaxy. Dust is not trivial. Each grain is a story written in structure. Some hold crystalline silicates forged in the heat of stars. Others preserve amorphous ices condensed in the cold between them. To imagine Atlas's coma was to imagine fragments of environments that no longer exist, slivers of suns long dead, clouds long dispersed. Polarimetric anomalies added weight to the idea. Only dust with unusual shapes, delicate textures, or compositions untouched for billions of years could scatter light in ways that defied known models. You traced the curves of data and felt the chill of time itself, as if the graphs were voices speaking from epochs before Earth had air. Comparisons helped frame the scale. Earth is 4.5 billion years old. The Milky Way's thick disk, where Atlas might have originated, is older still, with stars dating back 7 to 10 billion years. If Atlas's dust belonged to that epoch, then every particle was older than our planet, older than the crust beneath your feet. It meant the comet carried not just chemistry, but history written in matter. The body responded to this thought. Nights in observatories grew heavier, silence seemed denser. The faint glow of Atlas on screens a reminder of ancientness that dwarfed human scales. You leaned into that silence, breath tight, as though the act of watching brought you close to eras otherwise unreachable. Scientists spoke carefully. Words like primordial and cosmic relic entered papers, couched in caution but heavy with implication. No one could prove the dust's age directly, but its behaviour, its scattering, its spectral whispers all suggested survival across galactic epochs. Atlas might be less a comet than a shard of time, still glowing faintly green as it drifted past our sun. For centuries, humans had read comets as omens of future events. Atlas inverted this tradition. It was not about tomorrow, but about a past so vast it erased the boundary between myth and science. Its dust was older than memory, older than the sky as we know it. By late 2025, the thought settled in the minds of those who studied it. Atlas might carry the oldest solid material ever observed directly. Not a relic from Earth's formation, but from a time before Earth was possible. That realization turned every measurement into something more than data. It became communion with the earliest chapters of the cosmos. From such communion emerged a cautious conclusion. Atlas might not be only another comet, but the first sign of a category not yet named, a new type of interstellar visitor. Scientists avoided grand declarations, yet their words carried the weight of recognition. Something in Atlas defied the boxes where comets are kept. Its chemistry, its polarization, its silence of carbon chains, all pressed against the walls of classification. The language of papers became hesitant, heavy with phrases like may represent, possible subtype, unlike any previously observed. These were the careful steps of a discipline unwilling to leap but unable to deny the pull. You read the lines and felt the hesitation, like someone standing at the edge of a dark forest, knowing they cannot yet enter, but knowing the forest is real. Atlas forced comparisons with Oumuamua and Borisov. The first gave only its shape and strange acceleration. The second resembled solar comets in most ways. Atlas, however, stood between, visibly a comet, with coma and tail, yet chemically and optically an outlier. It was at once familiar and foreign, carrying signals that refused to reconcile with precedent. This tension became sensory for those who observed it. Nights stretched long, data logged endlessly, yet the feeling lingered that the comet was slipping away not only in space but in understanding. You stood at the console watching graphs appear, and the thought pressed in. This is something new, something unfit for old categories. Your breath caught in the cold, not from air but from the sense of standing before an unnamed frontier. The cautious framing echoed in every statement. Atlas might represent dust aggregates preserved from galactic dawn. It might reveal interstellar chemistry shaped outside our models. It might be the first of many such bodies, each carrying evidence that planetary systems across the galaxy compose comets in unfamiliar ways. For centuries, astronomy expanded categories: planets, asteroids, comets, moons. Interstellar objects are the newest additions, and within them, Atlas might be the seed of a further branch. To admit that is to admit we are still beginners, still learning the language of the cosmos. By the close of 2025, no one claimed final answers. Atlas was not solved. But in the silence of its green light and its strange dust, scientists recognized the possibility of a class yet unwritten. The new type did not have a name, but it had a presence, carried in the numbers, in the curves, in the nights of frost and breath. The search for Atlas did not stop with new observations. Scientists turned backward, combing archives for forgotten images, hoping to catch its trace before discovery. This practice, called precovery, is the archaeology of astronomy. not digging soil but sifting through data, looking for faint marks left by a traveller before anyone knew to look. Soon the traces appeared. In the massive archives of TESS, the Transiting Exoplanet Survey satellite, Atlas showed itself as a faint, overlooked dot. TESS had not been built to find comets. Its mission was to watch stars for the subtle dimming of exoplanet transits, yet in its wide frames collected tirelessly night after night, the comet's path had crossed. For months the data sat silent, just pixels among millions, until scientists retraced them with Atlas's coordinates. Suddenly the ghost in the machine became visible. The Vera Rubin Observatory added more. In test images captured between May and July 2025, Atlas appeared again, faint but steady, brightening gradually. At the time, it was just another point lost in calibration frames. Only later, once its orbit was known, did the dots connect. You picture the moment. Researchers scrolling through archives, hearts quickening as they saw the same point shift across weeks. The body reacts before the mind, a tightening in the chest, a surge of breath. At the realization that Atlas had been hiding in plain sight. For astronomy, such finds are gold. They extend the timeline of observation, turning a few weeks of data into months. With every added point, the orbital path sharpens, the uncertainties shrink, the story grows precise. Atlas was no longer a newcomer from July. It had been present in May, June, silent but real, waiting for recognition. The idea resonated with a world used to archives of another kind. Just as people search through old messages, photos, or security footage to understand a moment after the fact, astronomers search backward in sky records. The comparison is imperfect yet familiar. You scroll a phone for forgotten memories, they scroll the heavens for forgotten light. Both acts transform the past into revelation. What emerged was a continuity. Atlas was not a sudden apparition, but a body traced across months. The Green Wanderer had walked across detectors long before it entered headlines. Hidden in files, in servers, in stacks of raw data, it had already left its mark. Only now were we learning to see it. Those hidden marks became the foundation for precision. With pre-covery points added, Atlas's path sharpened, transforming from a guess into a certainty. What had been weeks of arc became months, and in celestial mechanics, time is clarity. Each added dot reduced the blur of uncertainty, tightening the lines of prediction until Atlas revealed itself fully, not bound to the sun, not looping back, but a visitor passing once. The calculations showed it beyond doubt. The eccentricity was greater than 6. The curve was hyperbolic, an open wound in the geometry of orbits. No comet born within the solar system could carry such a trajectory. Atlas was not ours. The confirmation carried weight like a final verdict. You stared at the numbers on the page, the orbit diagram glowing with its sharp curve, and felt the distance between human imagination and celestial fact shrink into one line. Precovery gave more than mathematics, it gave history. In May, June and July, Atlas had been climbing in brightness, almost unnoticed. The archives showed the gradual ascent, a body stirring as it fell inward. Each faint detection was a heartbeat, a pulse marking its entry into our neighbourhood. Now, stitched together, they formed a narrative. Atlas had been whispering for months before anyone heard. The precision changed everything. Predictions of perihelion grew tighter, dates and distances aligned with confidence. Forecasts of closest approach to Mars, Earth, and Jupiter could be trusted. Without those early points, the margin of error would have been vast, perhaps enough to cloud our understanding. With them, Atlas became a defined guest, its schedule written across the sky. Observers felt the difference. Without precovery, every night of watching would have carried doubt, every update wobbling with error bars. With it, they could follow with assurance, knowing where to aim, when to record, what to expect. You could almost feel the relief in the silence of observatories, the way shoulders eased when numbers fell neatly into place. The body responds to certainty as much as to mystery. The importance stretched forward as well as backward. If Atlas could be traced in archives, then how many other visitors had already passed unnoticed? Each precovery find was a reminder that telescopes collect more than they reveal in the moment. Data piles high, untouched, waiting for a reason to be read. Comets, asteroids, interstellar fragments, all may have left fingerprints, faint but durable. The future of discovery lies not only in the sky, but in the discipline of looking again. This idea carried a quiet revolution. Astronomy, once bound to the present moment, was now also archaeology of the sky. Precovery turned scientists into archivists, data into strata, telescopes into quarries of hidden fossils. You imagine scrolling through endless frames, eyes tired, mind dull, until suddenly one point shifts where it should not. The surge of recognition is physical, a spark along nerves, the body jolting awake, the past becomes alive. Atlas taught that visitors leave records whether we watch or not. Some records lie in the green light of a September night. Others lie buried in May images, overlooked until the need arises. To follow Atlas was to learn that astronomy does not begin with seeing, but with re-seeing, with the patience to let archives speak. By late 2025, the story was clear. Atlas was not only a comet of the present, it was also a comet of the past, inscribed months before its discovery, proof that light carries memory longer than attention, and in that memory we found confirmation of its interstellar birth. That confirmation did not settle the matter. Instead, it opened a new chapter of speculation, where the orbit of Atlas became less a number and more a riddle. From the start, its geometry had troubled researchers. The comet's path lay almost flat in the ecliptic, the plane of planets, tilted by only about 5 degrees. For most interstellar objects, entries are steep, crossing at odd angles, slashing through the solar system like arrows. Atlas was different. It slid along the same highway that Earth and Mars follow. Some scientists, including Avi Loeb, suggested this was too neat. Probability models put the chance at less than 1%. To Loeb, such a low likelihood justified bold questions. Could Atlas be artificial? A probe disguised as comet? A messenger deliberately sent? He did not claim proof, but he argued that the possibility deserved consideration. You read his words and felt the familiar spark of unease, the sense that behind the data, someone might be moving pieces. The comparison with Oumuamua was unavoidable. That first interstellar object discovered in 2017 had shown no coma, no tail, only a tumbling shard with unexplained acceleration. Some had whispered it was a solar sail, a relic of alien engineering. Those whispers never died. Atlas, arriving 8 years later, seemed to pick up the thread. Unlike Oumuamua, it showed activity, gas, and dust, unmistakable signs of a comet. Yet its orbit was just as strange, a near alignment with the planetary plane that defied expectation. NASA moved quickly to quiet the storm. Statements emphasized that Atlas behaved exactly like a comet should. It released carbon dioxide and water vapor, built a coma, grew a dust tail. Instruments measured sublimation consistent with sunlight striking ice. In every testable sense, Atlas fit the definition. Officials spoke firmly. It looks like a comet, and in every measurable way it is a comet. Still, the firmness revealed tension. For agencies, the priority was clarity. For the public, suspicion had already taken root. The geometry of the orbit looked like design, the green glow like signal. You imagined sitting in a control room, graphs glowing before you, hearing colleagues argue on both sides, one voice calling for restraint, another murmuring about coincidence too sharp to ignore. The body felt the pull of both arguments, the weight of science in one hand, the lure of story in the other. The arguments that stirred among scientists soon spilled into the public sphere, where precision gave way to sensation. Articles multiplied, each headline sharper than the last, framing Atlas not as a comet but as a mystery. Videos circulated, some earnest, some playful, speculating about alien craft wrapped in ice. Memes gave the comet nicknames: the green ship, the disguised visitor, the lantern from another world. In the space of weeks, Atlas became more than data. It became a character. Stories attached themselves to its orbit, its glow, its silence. For a world eager for narrative, the details of spectroscopy mattered less than the thrill of possibility. You scrolled past the images in imagination. Atlas drawn as a spacecraft with a glowing wake, its path across the solar system rendered like a voyage chart. The body reacted with conflicting sensations: amusement, curiosity, a faint chill of unease. For researchers, the spectacle was both frustrating and useful. Attention meant funding, headlines meant interest, but distortion threatened to overshadow truth. Scientists repeated their message. Atlas behaved like a comet. Gas flowed, dust trailed, sublimation matched expectations. Every metric spoke of natural processes, yet each repetition seemed like defense, a voice raised against a louder chorus of myth. Inside observatories, the tension was subtler. Teams logged data, whispered about papers, debated quietly. Still, the awareness lingered that outside these walls, Atlas has become a symbol larger than science. You stood beside the telescope, frost settling on the rails, screens glowing faintly, and felt the divide. Inside, the language of numbers. Outside, the language of stories. Both were real, and both shaped the way Atlas was seen. In the end, consensus remained firm. There was no evidence of construction, no trace of machinery, no anomaly that could not be framed in chemistry and physics. The orbit was unusual but explainable, the chemistry strange but not impossible. Atlas, scientists said, was natural, but even in their voices questions lingered. Why so much carbon dioxide? Why so little C2? Why such deep polarization? Each fact confirmed a comet, yet each anomaly whispered of something new. Atlas left a double imprint, in journals as a comet, in culture as a question. The Green Wanderer walked the line between certainty and story, reminding everyone who followed that the universe does not always fit neatly into either. The story did not end with debate. Ahead lay the most critical moment of all, perihelion, when Atlas would face the furnace of the sun. For every comet, this is the trial. At perihelion, the nucleus can awaken violently, spraying dust and gas in torrents, tails expanding like banners across the void. Sometimes the pressure is too great and the body fractures, leaving only shards and fading trails. With Atlas, uncertainty grew sharper. Its chemistry was unlike any seen before, dominated by carbon dioxide, deficient in the usual carbon chains, rich with anomalies. What would such a body do under the sun's closest glare? Astronomers marked calendars. October 29th, 2025. The date circled in reports, a crest toward which all observations flowed. Around the world, observatories aligned their schedules. Ground-based telescopes prepared to struggle against solar glare. Space-based instruments, above the atmosphere, would record in ultraviolet and infrared, where sunlight's interference could not overwhelm. For weeks leading up to that day, the anticipation was palpable. You felt it in every chart, every briefing, the slow rise of tension as though the comet itself was drawing breath. Perihelion is more than geometry. At 1.36 to 1.4 astronomical units, Atlas would not pass dangerously close to the Sun, but close enough for heat to matter. Solar flux at that distance is nearly 50% stronger than what Earth receives. For frozen volatiles, the difference is life or death. CO2 already dominated Atlas's emissions at 3 astronomical units. Near perihelion, the expectation was a storm. If buried water ice had survived beneath dust, it might erupt then, contributing new jets and altering the glow. If the nucleus was fragile, cracks could widen, the structure failing under thermal stress. The stakes reached beyond science. In the public sphere, Atlas had become a symbol. The Green Wanderer, the Maybe ship, the interstellar enigma. Documentaries promised to follow its passage. Articles speculated whether it would survive the solar trial or dissolve like comet YSON in 2013, which disintegrated near the Sun. Even in casual conversations, Atlas's name surfaced, not as numbers but as story. It had entered culture, and perihelion was the climax audiences awaited. Inside observatories, the tone was quieter but no less intense. Instruments hummed, domes creaked open in chilly dawns, operators leaned over glowing screens. You sat in such a room, the air heavy with coffee and silence, and felt the weight of expectation. Every pixel of data seemed like a heartbeat. It was the paradox of science, calm procedures wrapped around nervous anticipation. Some remembered history. The Great Comet of 1843 had unfurled a tail 200 million kilometers long at perihelion. Halley's Comet in 1910 had frightened cities with the rumour of cyanogen gas. In 2013, Eason had broken apart, its brilliance collapsing into dust. Each story was a precedent, a warning. Atlas carried the chance to join that lineage, though in its own strange way. By October, predictions split into camps. Some expected Atlas to brighten, perhaps even enough for binoculars. Others feared disintegration, its nucleus too fragile. Still, others thought it would remain modest, its chemistry never producing great spectacle, but offering clues in spectra alone. The divergence showed how little was truly known. You looked at those forecasts, columns of probabilities, and felt how thin human certainty is against the indifference of space. The date approached. October nights lengthened, frost formed on instruments, observatories filled with quiet concentration. Beyond the glass, Atlas curved inward, invisible to the eye but inscribed on screens. Every observer knew the same truth. Perihelion was not only about Atlas, it was about the limits of knowledge, the test of predictions, the humility of waiting. In that waiting, the comet was no longer distant. It was present, immediate, demanding attention. When the trial of perihelion passed, Atlas did not vanish. It bent outward again, fading from glare and preparing to return to morning skies. By November 2025, observers knew to look east before dawn, when the sky was still dark and the air cold with approaching winter. There, faint and green, Atlas would climb back into sight. It was no spectacle. Magnitude stayed low, the blur invisible to the naked eye. But for those who searched, it was a return. The sense of relief was physical. After weeks hidden in solar brilliance, the comet was visible again. Telescopes tracked it as it rose, tails thinner now, activity subdued. You stood at the eyepiece, breath clouding the glass, and felt the quiet joy of recognition. The same visitor, altered but intact, still walking the sky. The trajectory carried Atlas toward its closest approach to Earth on December 19th, 2025. Predictions held steady, 1.8 astronomical units, about 270 million kilometers. For space, it was a brush. For safety, it was infinite room. Reports repeated the phrase "no danger." The Green Wanderer would not come nearer. Its path was indifferent, a hyperbola already widening toward interstellar dark. Still, proximity carried weight. Instruments sharpened their focus, gathering spectra, measuring polarization, chasing every molecule that left the nucleus. Each detection became more precious, for everyone knew the time was short. By 2027, Atlas would be too faint, too far, lost again to the galaxy.